Intrinsic and extrinsic semiconductors. Semiconductors are materials that have electrical conductivity between that of a conductor, like copper, and an insulator, like rubber. Their conductivity can be influenced by temperature, light, and the presence of impurities. There are two main types of semiconductors: intrinsic and extrinsic. Intrinsic semiconductors, pure form. Intrinsic semiconductors are pure substances, meaning they don't have any impurities added to them. Equal number of electrons and holes. In an intrinsic semiconductor, the number of free electrons, negatively charged, is equal to the number of holes, positively charged. This is because the electrons are excited from the valence band to the conduction band, leaving behind holes. Low conductivity. Due to the relatively small number of charge carriers, intrinsic semiconductors have low electrical conductivity. Example: pure silicon, Si, and pure germanium, J, are examples of intrinsic semiconductors. Extrinsic semiconductors, doped with impurities. Extrinsic semiconductors are created by intentionally adding impurities to an intrinsic semiconductor. This process is called doping. Increased conductivity. Doping significantly increases the number of charge carriers, leading to a substantial increase in electrical conductivity. Two types. N-type semiconductor, doped with a pentavalent impurity, like phosphorus or arsenic, resulting in an excess of free electrons. P-type semiconductor, doped with a trivalent impurity, like boron or aluminum, resulting in an excess of holes. Practical examples: integrated circuits, ICs. The foundation of modern electronics, ICs, are made by combining P-type and N-type semiconductors to create transistors and other electronic components, diodes. These devices allow current to flow in only one direction, essential for rectifying AC signals to DC. Transistors. These are the building blocks of electronic circuits, used for amplification and switching. Solar cells. These devices convert sunlight into electricity using the photovoltaic effect, which relies on the properties of semiconductors. Light-emitting diodes, LEDs. These energy-efficient light sources emit light when current passes through them. In summary, intrinsic semiconductors are pure substances with low conductivity, while extrinsic semiconductors are doped with impurities to increase their conductivity. Both types play crucial roles in various electronic devices, shaping the modern world of technology.